Hello everyone. Here we come up with another series of lecture where actually you get an idea about the numbers representation. Okay, in this lecture I'm going to discuss about the topic we called it number system. Okay, number system. How a number that we can represent. What are the different ways that we can represent a number? Actually, if we see the in our daily life, we get numbers normally familiar. Suppose you are visiting on market, you are dealing with various kind of products. You are purchasing products. You might be selling the products, or suppose you are in a bank, so where you're depositing money. So again, that from the counter is asking how much money that you're going to deposit. So you are telling some numbers, correct? So what are the numbers actually we are faced in our daily life? This is actually called decimal number system. So actually, in this world of computer programming or data representation, a number can be represented actually in one of the four ways. But the most suitable number system that human is understood is the decimal number system. Okay, so basically we have this four number system. So here I am writing here. First one will have the decimal number system. Okay. Second one will have the binary number system. Third one will have the octal number system. And fourth one will have the hexadecimal number system. Okay, hexadecimal number system. So these are the four ways actually that we can represent, we can represent any number. Okay, so now let us discuss in detail about this number system one by one. Okay, so let's start with the decimal number system and let's see how it is actually look like. A decimal number system actually normally use a total 10 different numbers to represent a particular number. 10 numbers is actually used. Okay, 10 numbers. What are these? We all are familiar these numbers. This it is using the numbers like 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so how many numbers are there? 10 numbers. So that's why we call the base for decimal number system is 10 base. So by seeing the base, anybody actually, the people those are working in scientific domain, they always look for the notation, the base of a particular number. So suppose if you're telling them a number, suppose 65, you need to write the base along with the number. So anybody in the scientific domain, they can or mathematics people, they easily understand this 65 is a decimal number. Okay, so let's take some more example. Suppose you are writing a number 11, so you should add the base along with that number. So anybody now can understand. Okay, this number has been represented in decimal, so it is 11. So this is very common number system that we normally deal in our daily life. Okay, in almost every part of our daily life, we are generating such numbers, we are facing such numbers, we are giving some numbers. Okay, so now let's talk about the second one, binary. This is very interesting. This binary number system actually we also understand, but we normally not dealing with such kind of number system. This number system are specifically designed for the computers. Okay, computers. Because see, any such information that I have displayed under the decimal number, such as a number has 11 or number 65, these numbers actually converted to binary so that computer processor can process them. Okay, binary number system. Computers, we all know that it is an electronic device, so it is using only two numbers to represent a number in binary system. it uses the numbers like 0 and 1. 0 and 1 only. So how many numbers, whatever the numbers that computer is going to represent, it only will use these two digits. So two digits only. Suppose I am writing a number, something like this, 1 1. Okay, and if I put here base 2, so any people which is dealing with the computer programming or data, computer architect people or electronics engineers or scientific domain people, then easily understand this is a number in binary format 1 1. It's not going to be read 11. 11 it is in decimal. So careful guys. When you say 11, 11 in decimal, but it is never read it like 11. It is 1 1 and base is 2. That this number is represented in binary. So let me telling you actually what is this number all about. So you also get a little bit idea here. Okay, so here I am writing. Actually, this decimal 0 represented as 0 in binary as well. Similarly, decimal 1 is also represented as 1 into binary as well. Now, decimal 2, how it is actually represented? It represented, we need to combine these two digits only. So, we need to write something like this. Later, I'll tell you how we can convert a decimal to binary. Similarly, 3 will be the next combination. So, we can use next two ones. So now this is actually equivalent to 3 in decimal. Okay, so what about 4? 4 is 100, 5 is 101, okay, 6 is 110, 7 is, so whenever you saw the number of digits are all are 1, that means now for the represent the next decimal number you need to use one more bit. So first one will be 1, other will be all 0. Okay, and for the 9 the last one will be now 1. Okay, and for the 10 the second one will be 1, and for the 11 the last two will be 1. Okay, so all these numbers that I am representing here, it is in the formation of binary. Okay, so the base for the binary is 2. Now let's see another kind of number system that we normally deal in the computer or in the domain of mathematics. Okay, it's just a octal number system. Let me just put this L over here. Yeah, octal number system. Right. So now let us discuss about the octal. Where we see earlier the decimal number system consider only the okay, just okay. Here earlier we have seen that decimal number system using the 10 numbers to represent any particular number combination. By combining these 10 numbers only, decimal number system representing any number. But in octal, instead of 10, it considers only 8 numbers. Okay, it considers only 8 numbers. So what are these numbers? Just simple 0, 1, 2, 3, 4, 5, 6, 7. So any number which that you want to represent in octal, you need to use only these 7 digits. Apart from any other digits is not allowed for the octal number representation. Okay, not allowed. So now suppose that if you write something like this 717 and if you put it 8 over here, so anybody can consider this number has been represented in octal number system, not in decimal. So, okay, later we are going to see in the other part of the videos lecture that how we can convert this decimal number to octal number system. So just for the time being, you need to consider that an octal number system is only represented, any octal number represented using only these 8 digits. Now let's talk about the hexadecimal. Hexadecimal is actually going to use 16 you can say the numbers with alphabets in total. Out of the 16, it will use 9 numbers, and uh, sorry, it will use the 10 numbers and 6 alphabets. Okay, 6 alphabets. So let me list out all of them. The 10 numbers is very, now we understood here that it will be use the numbers from 0 to 9. Okay. What about these characters? It will use the characters like A, B, C, D, E, and F. So now if you count, there is a 6 character, and earlier there is 10 digits from 0 to 9. Okay, so by combining in total, there are 16 in numbers. So that's why the base for hexadecimal number is 16. Instead of this uppercase alphabet, we can also use the lowercase. A, B, C, D, E, and F. It is also allowed. So either we'll use the uppercase or either we'll use the lowercase. So let's take an example of hexadecimal number, how they're representing. Suppose here I am writing some examples over here, 113A, and I am writing here 16. So anybody will consider this is a number which is represented in hexadecimal format, neither in decimal, neither in octal, neither in binary. Okay, so similarly, if you write something here, suppose 23, and if you look at the combination, yes, 2, 3 is possible as hexadecimal number as well, but it is not 23, it is 2, 3 I am saying, and because if I say 23, it will be in decimal. So definitely we need to write the base with this, so that anybody can understand it is what? It is a hexadecimal number instead of decimal number or octal number. Because in octal also we can use 2 and 3 to represent any number, but then only base will help to understand what type of number it is. Okay, so now let's take the first one. Let's try to understand the decimal to binary first. How to convert a number to decimal to binary. Okay, so let us take an example over here. So if we had a decimal number, so we had a decimal number here, suppose 75 decimal. What do you want? We want the number in binary. We want the number in binary. So how to do that? So if you look at carefully, the base for the binary is 2 only. So what are you going to do? Divide this number 75 by 2 till the quotient part become 1 and save the remainder. So when you divide any particular number, suppose 6 by 2, so remainder in this case will be 0. Or if we divide an odd number by 2, okay, so remainder will be 1. So either remainder will 0 or either remainder will be 1. Okay, so repeat this step till the quotient part become 1. So if I divide 75 by 2, remainder is definitely 1 and the quotient part is 37. Now let's divide it by 2 again. So remainder is 1 and quotient part is 18. Divide it by 2, so quotient part become 9 but the remainder is 0. So again divide it by 2, the quotient part become 4 and the remainder is 1. And divided 2, again we'll get 2, remainder is 0. And at last divided by 2, we'll get the quotient part is 1, remainder is 0. So here we get the decimal in the binary form. So now what should I write? Place the number from bottom to top. Bottom to top. So now if I writing 75 in decimal is equivalent to this number 1, 0, 0, 1, 0, 1, 1. This is the binary number of 75. So normally your computer follow this approach to store any decimal number into computer memory. First of all, it converted to binary because machine understands this. So this binary coding system is also called a language called machine language. Okay, so I hope you understand how we have convert this number into binary. Let's take another example and then we'll stop. Let's take another example. Suppose let's take a small number 33 in decimal. What we want? We want to get the binary, equivalent binary. So what you need to do, divide this number by 2, save the remainder. Okay, repeat this step till the question part become 1 and place the number from bottom to top starting from the left hand side. So 1 0 0 0 0 0. Sorry, there it should be 1, the remainder, some mistake over here. So then it also should be 1, it should be 1. So, 1. So this is the binary number equivalent to 33 in decimal. So I hope you understand what is actually the number system and how a decimal number is representing into computer so that computer processor can process, which is called the machine code as well. So thank you very much. Do not forget to like the video and subscribe the channel. Click the bell icon and please share the video as well. Thank you very much.